The year is 2025. The hum of factories echoes across East Asia. Steel and silicon blend into something far more powerful than hardware, a new order in global power. A single decision edges closer to changing everything. China overtakes the global semiconductor industry. Suddenly, the world's tech dependence, its economies, its defense, all find themselves at China's mercy. What if China doesn't just compete, but actually controls the semiconductor market? Every node, every wafer, every cutting-edge chip. Tonight, we analyze the realities, the strategies, the resistance, the ripple effects. This is not science fiction. This is the future being built right now. Before we dive deeper, like this video, comment your thoughts, and subscribe. Your support helps reveal the forces shaping our technological world. This video is for educational and analytical purposes only. It does not promote aggression, tech dominance, or political manipulation. Our aim is awareness. Section 1. China's rising semiconductor power. In 2024 to 2025, the semiconductor world is already shifting. Global fab capacity, the plants that actually fabricate chips, is projected to grow 6 to 7% in 2025, with China increasing its share even more aggressively. China today is closing the gap. Its foundries are expanding in both mature nodes, chips made with older, larger transistor sizes, and pushing into more advanced ones, though still behind Taiwan and South Korea in bleeding-edge tech. China is also pouring investments into fabs and fab equipment. In 2025, global fab equipment investment is anticipated to reach roughly $110 billion, with a significant portion of that funneled into Chinese fabs. Another critical piece, rare earths and export controls. China currently supplies over 90% of the world's processed rare earth materials, essential for chip making, magnets, specialized metals, etc. New export controls from China are specifically targeting semiconductor and defense industries, restricting foreign companies' access. Meanwhile, the U.S. is trying to slow China's momentum. The Department of Commerce recently closed a loophole that allowed foreign-owned fabs in China to receive U.S.-origin semiconductor manufacturing tools without strict licensing. These validated end-user (VEU) privileges are being revoked or tightened. In short, China is increasing its production capacity, investing massively, controlling key inputs, rare earths, and pushing domestic self-reliance. The U.S. and other Western powers are responding with export bans, licensing restrictions, and strategic trade policy. Section 2. How China could move from rising to dominating. If China intends to fully dominate the semiconductor market, here are the levers it could pull. Manufacturing scale and amp, capacity expansion. China is pursuing expansion in both advanced and mature node fabs. While mature nodes serve a huge volume in consumer electronics, automotive, IoT, etc., advanced nodes, 7 nms, 5 nms, 3 nm, will be the strategic crown jewels for AI, military, and high-performance computing. The plan involves increasing domestic front-end fabs and attracting foreign equipment under strict licensing. Input control, rare earths and amp, tool accessed with rare earths export controls tightening, China can choke off external supply of materials essential for chip making. Meanwhile, access to high-end equipment, lithography machines, EUV tools, from firms like ASML or optics firms, is being restricted by the U.S. and its allies, making China depend more on domestic substitute tools or reverse engineering. Domestic innovation and amp. IP development, China invests heavily in R&amp, D for chip design, packaging, test, and assembly. Over time, as domestic toolmakers mature, they reduce reliance on foreign firms. The push in homegrown chip design is paired with AI research, local supply chains, and government subsidies. Strategic alliances and vertical integration. China could deepen its control by integrating all stages: raw minerals, wafer production, test divided by pack, and even final assembly. Countries that produce chip equipment or raw materials become either partners or targets for leverage. Regulation and export controls. As U.S. export controls on advanced chip-making equipment tighten, China's countermeasures include trade negotiations, retaliatory restrictions, or offering alternative supply routes. Beijing may also negotiate with certain countries to keep using their fabs or import critical tools under special terms. Section 3. Resistance and countermoves. What the West and allies can do. While China's posture is advancing, it faces resistance. U.S. Export controls and licensing. The U.S. has revoked fast-track licenses and tightened export controls on semiconductor manufacturing equipment. TSMC's fast-track status in China is being revoked. Subsidies and tech alliances. The U.S., Japan, Europe, South Korea are increasing incentives for local fabs. Government funding like U.S. CHIPS Act is designed to help produce chips domestically rather than relying on imports. Diversification. Companies are considering shifting production to Taiwan, Southeast Asia, or India. Taiwan's TSMC, South Korea's Samsung, etc., remain global leaders in advanced nodes. Material and rare earth strategies. Countries are seeking alternate sources for rare earths, setting up local mining and refining operations, and making stockpiles. Standard setting and diplomatic pressure. Trade groups, international forums, and diplomatic pressure can create networks of penalties for overdependence on Chinese supply chains. Section 4. Strategic and military implications. Semiconductors are the backbone not only of smartphones and AI, but of missiles, satellites, drones, and command and control systems. If China controls global chip supply, it gains a strategic weapon far more subtle and powerful than any bomb. First, think military systems. Next-generation fighter jets and missiles rely on advanced logic and memory chips. If U.S. partners or adversaries can't obtain those, their defense systems degrade. China could selectively throttle exports of critical chips or demand political concessions as payment. Nations become hostage to supply lines. Second, intelligence and cyber warfare escalate. China's dominance over the supply chain gives it insertion points, backdoors, hardware vulnerabilities, surveillance components embedded at the design level. If every advanced chip passes through Chinese realigned fabs, the risk of hardware tampering skyrockets. Third, asymmetric escalation. In a confrontation, China might cut off chip shipments to rival military powers, a gray zone strike without firing a shot. Imagine a standoff where satellite systems or missile guidance suddenly fail due to a chip embargo. Fourth, force projection without boots. China could prioritize military and dual-use chip orders over civilian ones, maintaining internal control while weakening rivals' technological edge. It could support allied states with chip grants or tech transfers, consolidating power blocks. Finally, escalation risk. A miswritten export rule, a customs seizure, or a supply glitch could be treated as an act of aggression. The line between trade war and kinetic war blurs when chips enable everything from drones to nuclear command. The battlefield of the future may not be fought in deserts and seas, but in factories, supply chains, and circuitry. Whoever commands semiconductors commands war. Section 5. Economic and technological fallout. The moment China dominates chip supply, disruption ripples through global tech, commerce, and innovation. Consumer electronics go first. Auto manufacturers, phone companies, data centers all rely on predictable chip supply. Price volatility spirals, production halts, product launches get delayed. Companies that once thrived may vanish overnight. Next, innovation chokes. Emerging economies without domestic chip production are cut off. Their startups die, AI talent shrinks, tech sovereignty vanishes. The innovation gap will no longer be a luxury, it becomes existential. Global supply chains split. Firms bifurcate into China standard and Western standard ecosystems. Think of a world where devices follow separate chip protocols, software stacks, and hardware compatibility, two parallel tech universes. Chip pricing surges. China can price to maximize revenue, effectively taxing foreign firms. Discounted chips become a diplomatic tool. China may grant cheaper chips to aligned states, while raising costs for adversaries. Financial markets fracture. Tech stocks suffer, chip firms tied to China dominate valuations. Investors hedge bets on alternative value chains. Nations transitioning away from dependence scramble to realign currencies, trade agreements, and industrial policy. The intellectual property economy fracturing is another blow. Licensing, chip design, patent regimes all become battlegrounds. China could force cross-licensing or claim reverse-engineered IP as indigenous. Lawsuits, sanction wars, and technology decoupling intensify. In short, control over semiconductors becomes control over civilization's nervous system. Whoever sets the chip standard writes the rules of tech, economy, and security. Section 6. Scenarios and possible futures. When we project forward, several possible futures emerge, some dystopian, some moderated, some balanced. Scenario A, the monopoly era. China achieves effective control over advanced chip supply. Western nations scramble to build alternate fabs, but the capacity gap is too large. China dominates global AI, defense, IoT, and autonomy platforms. The chip embargo becomes its most potent power lever. A new bipolar order forms, the China Tech Bloc versus the Western Tech Coalition. Scenario B, contested equilibrium. Competition intensifies. The US, EU, Japan, South Korea, India aggressively subsidize chip production and diversify supply chains. China retains dominance in many segments, but rivalry ensures dual supply. Chips become rival standards. Global tech fragmentation is the norm. Scenario C, backlash and reset. China's dominance triggers unified global pushback. Sanctions, trade treaties, and industrial coordination succeed in diluting its grip. Some of China's fab expansions shudder due to regulation or diplomatic pressure. The world returns to a multipolar chip market. Scenario D, hybrid domination. China controls high-end nodes, 3 nanometers, 5 nanometers, while the rest of world produces mature nodes, 28 nanometers, 40 nanometers. China holds the strategic choke point. Other countries maintain divergent tech stacks. The world evolves into layered dependency. Each path has winners and losers, and the global balance of power depends on timely policy, diplomacy, and investment choices. If China takes over the global semiconductor market, it doesn't just win a tech war. It rewrites the rules of power. Suddenly, trade routes matter less than chip routes. Diplomacy becomes about supply chain leverage. Military deterrence includes semiconductor cutoffs. Innovation becomes contested territory. To avoid this, the world must act fast. Nations must diversify fabrication, secure rare earth supplies, invest in domestic R&D, and build resilient alliances. Export controls, industrial policy, and tech federations may decide whether freedom or dominance shapes the future. The chip war is not a battle in the future, it's here, today. If this analysis resonated, don't forget to like, comment your view, and subscribe for more strategic geopolitics. Turn on notifications. Each new shift in tech or alliances could be the spark that follows next. We explore how power is built in circuits and chip fabs, not just on battlefields. Thank you for watching GeoPower Report.